Hi there and welcome to my channel. My name is Irfan and today we're gonna go through the Add Math paper 1 from May-June 2024, time zone 2. So let's go ahead and start with question number 1. Question number 1. I'm given the graph of a sine curve, as you can see here on this diagram, and I'm asked to find the value of a, b, and c, where a and b and c are constants. So if you look at this curve, the first thing you can notice is the amplitude of my sine curve. So just try to find the center line, which is right here. From there, if I go 3 units, I get to my maximum point. Therefore, my amplitude, or A, which is responsible for the amplitude, has to be 3. And then from there, I can go ahead and try to find C, because C is responsible for vertical translation. In other words, moving along the y-axis. So the normal sine curve is drawn basically from here, where the center line is the axis, the x-axis itself. Since I move down 4 units, so that means C has to be -4. Now lastly, it's down to finding the value of B. B is associated with the value of period, meaning which if you take the period of a normal sine curve, which is 360, and divide it by B, the coefficient of x, it gives you the period of the curve that we have. Right now, the period of the curve in front of me is actually 540. You can verify that by taking two corresponding points from two consecutive cycles. So basically this guy is nothing but 270. Also this is 270. So that means the period is 540. You cross multiply, you make B the subject of the equation. Therefore the value of B is found to be 2/3. Question number 2. I'm given a logarithmic equation and I have to find the value of RS. So the very first thing you have to do when it comes to solving a logarithmic equation is to make sure all the logarithms have the same base. So I prefer to keep the 3 right here and change the 9 somehow to 3. So it can be done if you remember the formula. If you want to introduce a new base into the equation, you just have to form a fraction. The arguments of the logarithms are going to be a and b, and then you just introduce the new base. Since I'm aiming for 3, I change everything here to 3, and then logarithm of 9 to the base 3, this is nothing but 2, and with the 2 in front it cancels out. Therefore I have logarithm of s to the base 3. Since this is summation, I can combine these logarithms. However, you need to multiply the arguments. Therefore I get rs, and rs is nothing but 3 times to the power of 8. This is the final answer. You can go ahead and write the number itself, get rid of the power, which is 6561. Question number 3. I'm given the equation of a tangent curve and I have to find the exact value of dy by dx when x equals to pi/3. In other words, I have to take derivative with respect to x and then substitute all the x's with this guy right here. So let's go ahead and start with taking derivative. As you know, the derivative of tan is secant square. However, you have to apply the chain rule since this is a composite function. That means you need to take derivative of outside, which is secant square x/2, and multiply it by derivative of inside, which is half. And then you can go ahead and substitute the x with pi/3. Once you do that, my argument changes to pi/6, and secant is nothing but 1 over cosine, and cosine of pi/6, that's a famous angle. It is square root of 3/2. Watch out for the index 2, and then once you apply that, you get 3/4. When you divide 1 by a fraction, the place of numerator and denominator changes. That means 4 goes up, 3 remains in the denominator, 4 with the 2 down here canceled out to be 2. Therefore, the final answer is 2 over 3. Question number 4. A team of 8 people is to be formed from 6 teachers, 5 doctors, and 4 police officers. In part A, I have to find the number of teams that can be formed. This is simply a matter of selection, so there is no arrangement or the order. So I can just go ahead and choose 8 people from the 15 people that I have, regardless of their jobs. So that would be 15C8, which is 6,435. In part B, I have to find the number of teams that can be formed without any teachers. If you exclude the teachers, the number of remaining people is 9, and I just have to choose the members of my team from those 9 people. So that would be 9C8, which is 9. In part C, however, I have to find the number of teams that can be formed with the same number of doctors as teachers. So a very wrong habit that some students have is to start calculation right away. I suggest you to, before even start any calculation, just to pause and count the number of scenarios or cases that you have. So if you look closely here, they want the number of doctors and teachers to be the same. So one of the possible scenario for me is to have 1 teacher and 1 doctor. However, it is not possible because there are 4 police officers, and with these 2 people, there is a total of 6. Therefore, there is no way you can have a team of 8 members. However, as soon as you increase the number of teachers and doctors by 1, we get to scenario number 2. So I have 4 people here, and I have 4 police officers. Therefore, I can form the team. So I have to choose these 2 teachers from the 6 teachers that I have, and I have to choose these 2 doctors from the 5 doctors that I have, and then I have to choose the remaining 4 people to complete my group from the 4 police officers, and that would be 150. In case number 3, I'm gonna have 3 teachers and 3 doctors. That means 6C3 times 5C3, and the remaining 2 members, I can choose them from the police officers. So that would be 1,200. And in the last scenario, I could have half of my team members to be teachers, the other half to be doctors. So I can choose the teachers from the 6 teachers I have here, 6C4 times 5C4, which is 75. So what I did here within the scenarios, I used multiplication because that's the AND scenario. However, over here, I use addition. So when you add up all the scenarios, you get 1,425. Question number 5. I'm given a trapezium ABCD, and I'm also given the length of the 3 sides AB, BC, and CD. I'm also told that the BC is perpendicular to CD and AB. I have to find the perimeter of the trapezium. So I already have the 3 sides. If I could find the value of the AD, I can add them up all together and therefore find the value of perimeter. So I have to find the AD first. The strategy I used here is I drop a vertical line downward to form this right angle triangle, and this value is known because it is parallel to BC, and it has to be the same length, square root of 7 plus 2, and I have to find this guy, the base, which is simply the value of CD, this guy, minus AB. Therefore, you get this, which also simplifies to square root of 7 minus 2. Now that I have the value of the base and the height, I can use Pythagoras theorem just to find the hypotenuse. So AD squared equals to the summation of each of those values square. You can use the famous identity here, the square of sum, a squared plus double of ab plus b squared, and if it's negative, like in this case, the sign here has to be negative. When you expand the brackets, this is what you get. You can combine the like terms and I get 22. The third will disappear because the magnitude is the same. However, the sign is different. Therefore, I get 8 AD to be square root of 22. Now, all I have to do is to add up all the numbers together. So AB is this plus BC, which is the square root of 7 plus 2 plus 9 square root of 7 minus 2 plus the value that I just found. So I can combine the like terms. 8 7 square plus 7 square, 8 square root of 7 plus third 7 plus 9 square root of 7. That would add up to 18 square root of 7 plus the square root of 22. And these three guys is nothing but negative 14. And that's the perimeter. In part B, I have to find the area of the trapezium, giving my answer in this form where P and Q are rational numbers. So the area of a trapezium is nothing but the half of, or the average of these two bases and multiplied by the height, and that's what I did here. So I added AB and DC together, divided by 2 and multiplied by the height BC. So first you need to simplify the expression inside this bracket. I get 17 square root of 7 minus 16 multiplied by this bracket. Then I have to expand it. I'm going to keep the half till the last time for simplicity. 17 square root of 7 times the square root of 7 is basically 17 times 7 plus 34 square root of 7 minus 16 square root of 7 minus 32. The like terms here become 18 square root of 7, and these two together is nothing but 87. And then you apply the half inside the bracket, which results in 87 over 2 plus 18 over 2, which is 9 square root of 7. In part C, I have to find the cotangent of DBC. I have to give my answer in the form r square root of 7 plus s, where r and s are simplified rational numbers. So over here, I drew the triangle DBC for you guys, and the BC, it's given to us. DC is also provided. We just have to find the cotangent of this angle right here, and cotangent is nothing but adjacent over opposite. So the adjacent is square root of 7 plus 2 over 9 square root of 7 minus 9. However, we need to rationalize this fraction because we're looking for a specific form here. So I have to multiply the top and bottom by the conjugate of the denominator. However, I'm not going to multiply this by 9 square root of 7 plus 9 because the numbers I'm going to end up with are going to be very large. So the trick I use here is I factor out 9 first from the denominator, and the remaining third, I took the conjugate of that and multiplied by top and bottom. So as a result, in the denominator, I can use difference of squares. So basically, I get square root of 7 square, which is 7, minus 1 square, which is 1. After tidying up the numerator and the denominator, which is 9 times 6, I get 54. Over here, I get 9 plus 3 square root of 7. You could continue by writing as 9 over 54 plus 3 over 54 square root of 7, which is 1 over 6 plus 1 over 18 square root of 7. And that is the final answer. Question number 6. I'm given a circle with radius 5 and the center O, and as you can see, I have the arc AB and arc DC. I also have this angle theta at the center. I'm told that COB right here is 0.5, which is in radian. Also, the length of the minor arc DC is given to me, which is 3.75, and I'm supposed to show that theta is 0.75. So I'm going to refer you guys to the equation of the length of an arc, which is r theta, and that means 5, the radius, times theta has to be equal to the length of the minor arc DC, which is 3.75. You cross multiply, theta is found to be 0.75. In part B, I have to find the perimeter of the shaded region, and that carries 5 marks. So if you want to find the perimeter of the shaded region, you need to have the value of the line segment DC, AB, and also the length of the arc CB and AD. However, AD and BC they're identical. So I'm gonna go ahead and start by finding the value of AB, and that can be found using cosine rule. If you look at this triangle, these two sides are known to me. Also, the angle here can be found. I already know the value of theta. This is 0.5, 0.5. The theta is 0.75. Together, it is 1.75. You apply the cosine rule, you get this expression. You just have to tidy up. 5 squared plus 5 squared is 50 minus 50 cosine 1.75, which gives you 7.675. Now I have to find the value of DC. I'm going to apply again cosine rule. For this time, still the radius is 5. The angle between the two sides, however, is reduced to 0.75, and that's what you can see here. I have to take the square root of the right hand side, tidy up, key in these values into your calculator, and this is the final answer you get. So if you add up these two, that takes care of the straight edge of my shape here. For the curve side, AD and CB, I have to use this formula right here, which is the length of an arc. The angle is known, the radius is known, so 5 times half, which is 5 over 2 or 2.5. That would be the value of AD as well as CD because they're identical. You add them up all together and you get 16.3 after rounding to 3 significant figures. Question number 6, part C. In this question, I have to find the area of the shaded region. So I did this drawing here, guys, to walk you through it, basically what I did. So if this is the area to be found, the blue region, it can be found easily by taking the whole area of this sector and then subtract the red region above here as well as this segment down here. So let's go ahead and find the areas of each of these sections one by one. So the area for this part can be found easily by applying the formula half of theta r squared, and that's what I did here. The theta is this whole angle, which is 1.75, that's in radian. And for this section, since this is a triangle, you can use the sine formula for the triangle, which is half of AB sine C. So A and B is the radius, which is 5, therefore you get 5 squared, and sine C is sine of this angle, which is 1.75, minus this guy right here. But this has its own story. You need to find the area of this whole sector right here, which is again using half of theta r squared, and subtract the area of this triangle from it, which again I use the same formula, half of AB sine C, but the value of the theta is now 0.75, while the radius or the side remains the same. So you can go ahead and key in everything in your calculator, and the final answer would be 8.7. Question number 7, part A. We're given the equation of a straight line, y equals to 3x minus 2, and we're told that it intersects with this curve at 2 points A and B. The point C with x coordinate of k and y coordinate of 7 over 8 lies on the perpendicular bisector of line AB. Find the exact value of k. So basically, let's say if this is my curve and this is the line, these would be the 2 points A and B. This is the bisector. I need to find out the midpoint. So there is a point such as C with the coordinates k and 7 over 8, which lies on this bisector. So it's very obvious that I need to have the equation of the line of the bisector. However, in order to find that, I need the slope of my AB because these two after all are perpendicular as the equation told us. I'm just going to go ahead and start by finding the points A and B itself. All I have to do is to make a substitution here and replace all the y's with 3x minus 2, and this is what I get. So I just expand the brackets. Over here I get negative 3x squared plus 2x. Here I get 9x squared minus double of their product, which is negative 12x, plus this guy square, which is 4. It has to be equal to 2. You tidy up, you add up the x squared terms together, x terms as well, and bring this constant over here. 4 minus 2 become positive 2 is equal to 0. And this is a quadratic formula, which is going to lead us to two distinct answers. You can start by dividing everything by 2. You get 4x squared minus 5x plus 1. What I did here is I use factorization method. This is a very easy quadratic equation to factorize. You can use any other method to find the answers. So this factor equals to 0 leads to x equals to 1. If you put this equal to 0, it leads to x to be 1 over 4. I need to find the corresponding y values. And if you go back to the equation of the straight line, make the substitution, you should get 1 for this guy, and you should get negative 5 over 2 for this. You could also make the substitution in the curve, but however, given the complexity of this equation, it is not advised. It would be very time consuming. After all, these 2 points A and B, they both lie on the line as well as the curve, so it must satisfy both equations up here. So we're not told which one is which, but you can label them or you can just leave it like that. Now I need to find the value of my midpoint. I can just go ahead and take average of the x's and do the same thing for the y's, which leads to the x coordinate of the midpoint to be 5 over 8 and y coordinate to be negative 1 over 8. And then I'm going to find the slope of my line AB. And that can be found using the famous formula y2 minus y1 over x2 minus x1. In other words, rise over run. So I took this guy to be y2. That means negative 5 over 4 minus 1 over 1 over 4 minus 1. And that is nothing but negative 9 over 4 divided by negative 3 over 4. The 4's are cancelled. Same as the negative sign. 9 over 3 is positive 3. But this is not the slope of the bisector. This is the slope of the line AB. The slope of the bisector, since it's perpendicular, applying this formula, it should be the negative reciprocal of 3, which is negative 1 over 3. Now that I got the slope of the bisector as well as a point on it, which is the midpoint, I can go ahead and find the equation of the bisector using this famous equation. Y minus y1 equals to m times x minus x1. Well, m is negative 1 over 3. x1 and y1 are these two values respectively. Now, you do not need to tidy up and make y the subject of the equation. That would be a waste of time. All you need to do, since they want us to find the value of k, you just need to replace the y with 7 over 8 because this point C lies on this line, so it must satisfy the equation of this line. So you make the substitution and then you try to make k the subject of the equation. Over here I got 7 over 8 minus 1 over 8, which is plus 1 over 8. The whole thing becomes 1. Over here you can expand the bracket. You get negative 1 over 3 times k plus 5 over 24. You combine these two fractions, you multiply here by 8, also the numerator, you get negative 8k plus 5 divided by 24. You cross multiply and get rid of the 5, bring it to the other side, it's become negative 5, divide both sides by negative 8, which results in negative 19 over 8, and that's the value of k. Question number 7, part B. I'm told that the point D lies on the perpendicular bisector of AB such that D is a reflection of C in the line AB. Find the coordinates of point D. So here's the thing. Imagine these 2 points represent A and B, and then this is the bisector. So if this is point C, the reflection of that about point AB would be right here. So the strategy I used here is very simple. You just have to ask yourself, how much do I need in order to go from C to point M, or the midpoint? If I continue that path, or if I move forward same amount in the X direction and same magnitude in the Y direction, I should get to point D. So therefore over here, all I have to do is to find how much do I need to go from -9/8 to 5/8. And I can find that out with simple subtraction. That would be 24/8. So I just add 24/8 to 5/8, and that gives me the x coordinate of point D. I can do the same thing for the y coordinate and find the difference between the y coordinate of the midpoint and C. Simply by subtracting them, I get -1, and then I continue in that direction with -1 value, and I get to -9/8. However, this is not the exact presentation of what's happening here. This was just to give you an idea of what's going on. Obviously, since the y coordinate of point D is less than the midpoint, so it would look like something like that. In reality, we're going down basically, but you get the idea. So that is the final answer to question number 7, part B. Question number 8. We're given the equation of a curve, and in part A, I have to show that dy by dx can be written in this form where a, b, and c are integers. So since this is a fraction, obviously I have to use quotient rule. So the quotient rule says if you're dealing with the fraction and if you want to take derivative of that, all you have to do is to raise the denominator to the power of 2, take the derivative of numerator, multiply that by denominator, and minus the numerator times derivative of denominator. So I have color coded the process here in green after taking derivative and all the changes that I have made. So if you take derivative of numerator, you have to be careful. This is obviously a composite function, and I'm just gonna take derivative of outside, which is 1/3, and then you need to subtract 1 from the existing power, and don't forget to multiply it by the derivative of inside, which is 6x, and of course don't forget to multiply it by the denominator as well, just like the formula, and then minus the derivative of denominator, which is 1 multiplied by the numerator. After that, it's just algebraic manipulation. We need to tidy up till we get to the desired form. So the first thing I'm going to do, since 1/3 minus 1 is -2/3, I'm going to change that negative power to positive by bringing it down into the denominator. And then this is what I get. So I want to unite all these and get a single fraction. Therefore, I'm going to multiply top and bottom by the denominator of the first fraction. So this is what I get. And after I do that, if you look over here, these two terms are exactly the same. Add the powers together, 1, and that's what I got here. Don't forget to put the negative. Also here, you just have to expand the bracket, which results in 2x squared plus 8x, and the whole thing has to be divided by x plus 4 squared. And the last thing you have to do, you can just lend a tiny one to this guy. So this times this over this times this, which gets me to the final answer of -x squared plus 8x plus 5 over the expression that they already indicated in the question itself. Therefore, A is -1, B is 8, and C is 5. In part B, I have to make use of what I found in part A because they use the word hence, and I have to find the x-coordinate of the stationary points on the curve. I have to give my answers in the simplest exact form. So for stationary points, it's very obvious. I have to put the first derivative equal to 0. So since the first derivative over here was a fraction, the only way a fraction can become 0 is when the numerator is 0. That's why I took this guy and put it equal to 0. For simplicity, I multiplied everything by -1 just to make the leading coefficient positive. And after that, it's very obvious that factorization doesn't work since they use the word simplest exact form. It is kind of a hint that you can't simply end up with integers as your roots. So I'm just going to go ahead and apply quadratic formula. First, you need to determine the a, b, c, or the coefficient of your leading term, the x term, and the constant. Those are 1, -8, -5 respectively. And go ahead and substitute it in this famous formula. Watch out for the -b here in front of the -8, plus minus. So here I get 64 minus with minus is positive, so 64 plus 20, that would be 84, which can be divided by 4. So I just write it as 4 times 21. Therefore, the 4 can come out, become 2. Over here, minus with -8 is +8. And everything here is divisible by 2. Therefore, I'm going to go ahead and do that. In the numerator, I get 4 plus minus square root of 21, which cannot be simplified further. And that's my final answer. Question number 9. In this question, all distances are in meters and time is in seconds. A particle P moves with a speed of 14.5 parallel to this vector. Find the velocity vector of P. So if you want to find the vector which is parallel to this, however, got a different magnitude, so I have to use scalar product. So in order to know which fraction of this vector I have to use in order to get my desired new vector, I'm just going to go ahead and find the magnitude of this vector. I can use Pythagoras theorem. So x component raised to the power of 2 plus y component raised to the power of 2, take the square root of the whole thing, you get 29. So 14.5 is half of this value. So all I have to do is to multiply half to this vector, and since it's in the same direction, I do not need to change the sign of x nor my y component, and that's the velocity vector. So we're told that initially P has position vector 3, 5. Write down the position vector of P at time t. So since this is a position vector, so that means I'm starting at here 3, 5, and then I'm moving using this velocity vector, which is basically -10 and 10.5. And that would be the direction that I'm traveling every second. So I'm just going to write 3, 5 plus t times -10 and 10.5. And then I'm told that a second particle Q has position vector of this at time t. I have to find in terms of t the distance between P and Q at time t, and I have to simplify my answer. Well, it's a very simple question. If you want to find the distance between two vectors, you just have to find the difference between the corresponding components. So I'm just going to go ahead and find the vector PQ, which is nothing but Q minus P, and that's what I did here. So I get a vector PQ. However, distance is the magnitude of that vector. Again, I can use Pythagoras theorem, raise the x component to the power of 2 and add it with the square of the y component. You expand the brackets, you get positive 16 minus double of the product of these two, which is -40t, plus this guy raised to the power of 2, which is 25t squared, and then plus same thing here, -2 squared is 4. Double of the product of these two is 12t plus the square of this guy, which is 9t squared. So if you tidy up and add up the like terms, the t squared term comes out to be the 40 squared. The t term is -90t, and the constant is nothing but 20, and that's the distance between P and Q at time t. In part D, I have to show that P and Q never collide. They're using the word hence. That means I have to make use of what I found here. So this is a very simple question, actually, if you think about it. If P and Q collides, that means the distance between them can become zero at some point. In other words, there is such a t that make this expression to become zero. So if we prove that this can never be zero, that means they would never collide. So I'm just going to go ahead and put this equal to zero. Since this is under the radical, that means this whole thing has to be equal to zero. Determine the A, B, and C if you want to show that this quadratic equation is solvable. In other words, if there are any real roots, all I have to do is to show that the discriminant is positive or greater than 0. So when you find the b squared minus 4ac, you make the substitution, you realize the number come out to be negative. That means there are no real solution. Therefore, this can never be 0, and that means the particle P and Q would never collide. Question number 10, part A. The first three terms of an arithmetic progression are 3 sine 2x, 5 sine 2x, and 7 sine 2x. And in part 1, we're supposed to show that the sum to n terms of this arithmetic progression can be written in this form. So since they're talking about the sum to n terms, I'm going to be using the formula Sn, which for arithmetic is half of n times 2a plus n minus 1 times d, where a is the first term and we have it right over here. However, d is unknown, so I have to find d, and that can be simply found by taking two consecutive terms. In this case, I took the second and the first term, and then find the difference between those, and that is nothing but 2 sine 2x. And now it's time for substitution. You're just going to substitute a, which is 3 sine 2x here, and then do the same thing for d as well. Now we have to tidy up. You can expand this bracket. If you do that, you get 6 sine 2x for the first one. You get 2n sine 2x, and finally negative 2 sine 2x. And then I have to multiply half of n into each term inside this square bracket to get rid of it. 6 divided by 2, that would be 3. There is an n right there. So 2 and 2 cancels also for the last term, and all of them, they're gonna have an n term appear in front of them. Watch out for the n, which was already here. N times n, that's n squared. And now I have to tidy up. 3n sine 2x minus n sine 2x gives me 2 sine 2x. And since I have sine 2x everywhere, I'm gonna factor it out. After all, that's what they want me to get in the end. If you do that, you're left with n squared plus 2n. Even though this is the final answer, you have to continue one more step because they're looking for a specific form, and that can be achieved by factoring out n, and therefore the a will come out to be 2. In the second part, I'm given that x equals to 2 pi over 3. I have to find the exact sum of the first 20 terms. So still I'm going to be using the same formula, but this time instead of n, I can replace the n's with 20 since I'm asked to find the sum of the first 20 terms. However, instead of using general terms such as 3 sine 2x and 2 sine 2x for a and d respectively, I can now substitute them with their exact value because I'm given a specific value for x, which is 2 pi over 3. So when you make the substitution, over here the argument of sine is 4 pi over 3, and that's a famous angle. If you refer to the unit circle, is the negative version of the sine of pi over 3. And the sine of pi over 3 is actually square root of 3 over 2. Don't forget, you have to put negative there. And if you make the substitution, when you combine it with the coefficients in front of my sine term, these are the numbers that you get. Now go back here, instead of a, substitute this value. Instead of d, substitute negative square root of 3. And then over here, the 2 vanishes. Here I got negative 19 square root of 3. Together it comes out to be negative 22 square root of 3, which when you multiply it by 10, you get negative 220 square root of 3. In part B, however, I'm dealing with a geometric progression. And again, the first 3 terms are given to me. I'm supposed to find the nth term of this geometric progression. So if you refer to the nth term, the formula for the nth term in a geometric progression, it's nothing but a times r to the power of n minus 1, where a is the first term, ln of 2y in this case, and r is the common ratio, which can be found by dividing just two consecutive terms from your progression. So I'm taking the second term, dividing it by my first term, and I'm just going to go ahead and use the logarithmic law to make the argument the same. Therefore, hopefully I can cancel them. So 4y squared can be written as 2y squared, and these two can be brought down here in front of the ln, and then I end up with ln 2y over ln 2y, which cancels out together, and I'm just left with these two. So that's the r. You just go ahead and make the substitution, and this is the nth term. In the second part, I have to find the sum to n terms of this geometric progression, giving my answer in its simplest form. So if you refer to the formula for the sum up to the nth term, it's actually a times 1 minus r to the power of n divided by 1 minus r. And that's what I did here. It's just a matter of simple substitution. You do that, everything is divided by -1. Also, you can expand this bracket, and this is what you get in the end. In part C, I'm given the first terms of a different geometric progression. As you can see here, these are the first three terms. Find the values of W for which this geometric progression has a sum to infinity. So if the geometric progression converges as these terms keep increasing and basically go up to infinity, that means the absolute value of the common ratio has to be less than 1. In other words, 1 has to be between -1 and 1. So you have to find the r and then substitute it in this inequality to find the range for w. So again, finding the common ratio, you just have to take two consecutive terms and divide them by each other. And that's what I did here. They are like terms but different powers. So you just subtract the powers, 2 minus 1, you get 1. So this is my common ratio. I put it between -1 and 1. So I have to get rid of the negative quarter here as well as 2. So what I did here, I add everything by 1 over 4 just to get rid of this -1 over 4 here. The middle term is reduced to 2w. And lastly, I need to also get rid of the 2. And I do that by dividing every single term here by 2, and I get w to be greater than -3 over 8 and less than 5 over 8. Question number 18, part A. Given that y is equal to x squared ln x, find the first derivative, or dy by dx. So since I have the product of two functions here, I'm going to go ahead and use product rule using this formula, which says the derivative can be found by finding the derivative of the first function multiplied by second plus derivative of the second function multiplied by first function. And I have color coded here, so that means the derivative of x squared is nothing but 2x times the second function ln x plus the derivative of ln x is 1 over x and multiplied by the first function itself, and it simplifies to 2x ln x plus x. In part B, I have to find the integration of x ln x with respect to x using what I found in part A, because they're using the word hence. So let's go back to part A and see what actually happened. Well, since integration is nothing but antiderivative, that means over here, if I take integration of this guy, I should get back to where I started taking derivative, and that's what I wrote down here. And after that, you need to somehow extract this guy from what you have on the left hand side. So the first thing I did, I split this integration into two simplest one. And once you do that, you kind of see this x ln x dx over here, but be careful of the coefficient. The 2 can be brought outside, and later on I will take care of it by dividing everything by 2. But first, let's get rid of this integration. You need to bring it to the other side and take integration. Integration of x is nothing but x squared divided by the new power, which is 2. And lastly, you need to divide everything by 2. But don't forget, since I took integration here, there must be a constant of integration. You can either apply it here or just apply it at the end of your solution, just like what I did. And this is the final answer. Having said that, this was the last question for this paper. I hope you enjoyed the video. Please leave me a comment if you found any question challenging or you need further explanation for any specific question. See you guys with another past year paper. Thank you.